it? X is between, you can see here, y from the given integrals, double integrals, we can see that y is between the numbers y is between the numbers -2 and 0, and x is between the numbers functions x is greater than or equal to y squared and less than or equal to 4. Yeah, so this is the region R for the double integral here. So let's make a sketch. Yeah, let's make a sketch of this region on the xy plane. So we have this x equal to y squared. Okay. We have this equation x equal to y squared. X equal to y squared. What is a? It's a parabola, right? That opens to the, excuse me, that opens to the right, isn't it? It's a parabola that opens to the right. Yeah. So you need to know this, some common shapes of common curves or common surfaces. Yeah. And then x is further bounded by 4. X is bounded on the left by y squared, and it is bounded on the right by this straight line here. Yeah. So this is the line x equal to 4. Okay, what about y? Y is bounded between -2, y. So -2 is here. Okay, because x is y squared. So when when y is equal to -2, x equal to 4. Yeah. And y is between -2 up to 0, so that means this region only, right? This is the region R. So you need to get this sketch, correctly. So now, to interchange the order of integration, you want to have x between numbers. Instead of y between numbers, now we want to have x between numbers. So it is clear that from this diagram, x is between 0 up to 4. What about y? Anybody? Y is between?
Negative square root of x to
Yes.
4.
Yeah, x is y squared, right? So the upper arm is y equal to square root x. If you solve for y, yeah? If you solve for y, then you will get y equal to plus or minus square root x. So the positive square root x refers to the upper arm. So the bottom curve refers to y equal to minus square root x. So y is bounded below by minus square root x and bounded above by the x-axis where y is 0. Okay, so this is the new limits, yeah, for the double integration. So if I denote this as I, then I is equal to the integrand is y sine x squared. Now we want to use the order dy dx. So the inner integral is respect to y. So y has the lower limit minus square root x and the upper limit 0. And x is between 0 and 4. Okay. Okay, why do you think we need to change the order of integration? Because it is difficult to integrate sine x squared, It's not how to integrate sine x squared. Yeah, we know how to integrate sine x, but for sine x squared, the integral of sine x squared is unknown. Yeah. So one way is to integral, but with respect to y first. Uh, the integral of y is half y squared. So integrate y. Okay. The integrate y with respect to y, it is y squared over 2. Y is between minus square root x and y equal to 0. Okay, so write down your solution clearly, clearly. So there's a constant 1/2. I can pull out the constant 1/2. Sine x squared. Okay, now we substitute the limits. When y is 0, it's 0. When y is minus square root x, it is x squared, right? X squared dx. I'm sorry, x. It is not x squared, x. When y is minus square root x, y squared is equal to x. Okay, so this is the same as I pull out the minus sign. So now the integrand, the integral reduces to a single integral here. So I'm sure you know how to evaluate this single integral. What technique to use?
Substitution of u.
Substitution. Say u equal to
X squared.
x squared. Yes. So du is 2x dx. So it is minus a half sine u. And x dx becomes du over 2, right? Becomes du over 2. Yeah. Now the limits also change, right? When we do this substitution, when x is 0, u is 0. When x equal to 4, u equal to x squared, which is 16. So this is minus 1 over 4, the integral 0 up to 16 sine u du. So I'm sure you can, complete the what calculation here. All right. Any question?
Doctor, should we left the answer to be in form of terms of cost and over something, or we need to get the value up there up? Yeah.
You can use the answer. You can leave your answer in terms of cosine. Okay.
Then
You don't
in
have
the
to use your calculator, right?
oh,
Uh,
and then the cost in the cost, if the inside the cost I got cost 16, right? The 16 is
yeah.
in degree or in
Oh,
radian?
it should be in radian. It must be in radian, not degrees. Yeah. You see, for example, the integral of sine u is cosine minus cosine u, right?
Yeah.
Minus cosine u, and u is between 0 up to
So
16. So minus and minus give us plus. So that gives cosine 16 minus cosine 0, right? Cosine 0 is 1. So you can leave your answer in terms of uh, this form. If you want to use your calculator, you must use radian, not degrees. Okay? You must use radian mode. This is 16 radian, not 16 degrees. Okay? All right. But you can leave your
thank you,
answer in
doctor.
this form. Yeah, sure. Any other question?
Doctor,
Mm-hmm.
I have a question.
Yes.
I'm not clear about how you change the The 4 to the 16.
Oh, because we have this what the substitution, right? We have the substitution u equal to x squared, right?
Oh, so x
Uh,
squared 4
yeah.
power of 2,
So
right?
the
Okay.
original limit is for x, right? So when x is
Mm.
0, u equal to 0. When x equal to 4, u equal to x squared, which is
X squared
16.
16.
Okay? Yeah.
I understand.
Mm-hmm. Any other question? Okay, let's do another example. There will be applications as well, right? For example, calculating mass, center of gravity or centroid. What else? We also have what else? The moment, right? The moment, inertia. Yeah. So let's see. Suppose we have. Let's see another example here. Related to mass. A lamina with density say delta xy equal to square root of x squared plus y squared is bounded by the circle, say x plus 2 squared plus y squared equal to 4. What else? And lines. Okay, let me write first the equation in this form. X squared plus y squared plus 4x equal to 0. And the lines y equal to plus or minus x. Find its mass. Okay. Suppose we want to find the mass of this plant, mass of the lamina, right? The mass of a lamina. Lamina is a thin sheet of material, right? Okay, let's what do we need to do here first?
Sketch a graph.
Sketch a diagram.
Yeah, sketch the shape of the lamina, right? Want to sketch the shape of the lamina. Okay, what this circle? What is the center point? What is its radius? That's what we also need to determine before we can sketch the circle. We can complete the square, right? Complete the square for the term with x. So you need to know this. Completing the square. We have used this several times. So how do you complete the square? X squared plus 4x plus what? Plus
Plus 4 minus 4.
plus 4 minus 4. Isn't it? Yeah. Why 4? You look at the coefficient of x, right? Which is 4.
Yeah.
You divide it by 2 and then you square it. Yeah. That's why you get here 4. But when we add 4, we must take away 4. See? So in this way, so the sum of the first three terms can be written as x plus 2 squared, right? Yeah. So the final equation is x plus 2 squared plus y squared equal to 4. Yeah. and 4 is 2 squared. So what is the center? What is
2.
the center of the circle?
Yes.
2-0.
Negative 2.
No,
Negative 2.
yes, not 2 0, but negative 2 0. Yeah, and the
Oh
radius?
yeah.
Yeah, radius is
2.
2.
2.
Okay, so don't make careless mistake. Yeah,
Yeah, sorry, sorry.
because this will affect everything. Later on, if you make a careless mistake in this initial part. So now let's sketch the region. We have a circle centered at minus 2 0 of radius 2. So looks something like this, yeah. Centered at minus 2, and it is also of radius 2. So this is minus 4. And they are given two lines as well. The line is y equal to plus or minus x. So this is one line, y equal to x. Oh no, this is minus x, right? Minus x. You have another line in the other direction here. Y equal to x. So where is this region of the lamina? Bounded by this circle and the two lines. Bounded by the circle and the two lines.
The big one. Yeah,
The big
the big
one.
part.
Yeah, it must
The
be
big
this
part.
one. Okay? Must be this one then. So this is the region R of the lamina. Uh, So what is the mass? What is the mass? It's a double integral of the density function. This one, right? Is the mass formula for a lamina with density function delta here. Now, what are the limits? What are the limits?
Doctor, this should be used polar coordinate, or we
Yes,
separate two part in
yes.
rectangular.
It you see, it is, yeah. The idea is to use polar coordinates. For this kind of problem, you should use polar coordinate. It is, even though it is not stated here, right? But you should be able to figure out that the polar coordinates is useful here. Okay, sometimes student might think wrongly, that they might think that, okay, x is between minus 4 and 0, and y is between minus x to x. Now this is not correct. you know If x is between minus 4 and 0, y is between minus x and x, R is a triangular. I is a triangular region. You know, so so this set refers to a triangular region. So it had nothing to do with the circle at all. Nothing to do with the circle at all. Yeah. This is the region. If you think this way. So this is not correct, right? Because the region R is not triangular. So so it is difficult, to evaluate this double integral using Cartesian coordinate, because you have to split this region R into two. If you want to use the Cartesian coordinate, you need to split this integral into two. Okay. So the best way is to use the polar coordinates. Okay. So what is r in terms of polar coordinate? Can anybody tell what is r in terms of polar coordinate? Yes. R is between what and what? Now we need to have a polar curve for the circle. Okay. So R is between what and what? We know it is greater than 0. What about theta? It is between what angle and what angle? Okay, so we need to have a polar equation for this circle here. So go back to the Cartesian equation. We replace x by r cos theta, y by r sin theta. We get r squared, isn't it? For r x squared plus y squared. And then x become r cos theta. So that gives r squared equal to what? You can factor out r plus 4 cos theta equal to 0. So r cannot be 0. R must be, so we must have r equal to minus 4 cos theta. Okay. So the equation of the circle is r equal to minus 4 cos theta. Now theta is between what and what? Yeah. What is this angle here? What is this angle here? Theta is from this angle up to this angle.
3 pi over 4 to negative 3 pi over 4.
Yes, theta is between this angle here is what? 3 pi over 4, right? And this one is 5 pi over 4, right? This one?
Yeah, or it can be negative 3 pi over 4.
What?
Can it be negative 3 pi over 4, like another way around than taking the
Oh,
negative?
then you are going this way. You see, the theta sweeps from this line to this line, from the line, the red line above until the red line below. Okay, the theta sweeps from the line above, from this line to this line. So let's use theta between 3 pi over 4 until 5 pi over 4. Okay. So here theta is between the angle 3 pi over 4 until 5 pi over 4. Okay. Yeah. Any question? So therefore, now we can construct the equation for the mass using what is rho, what is delta? Delta is square root of x squared plus y squared, which is what? Square root of r squared, isn't it? Square root of r squared, then dA becomes r dr d theta. Okay, so r is from 0 up to minus 4 cos theta. What about theta? Theta is between 3 pi over 4 up to 5 pi over 4. Okay, and this square root r squared times r is the same as r squared. So first we integrate with respect to r, which is r cube, isn't it? R cube over 3, and r is from 0 up to minus 4 cos theta. Yeah, dt theta here. So if we substitute, okay, we can pull out 1/3 there. We have here 3 pi over 4. What else? 5 pi over 4. So when we substitute r equal to minus 4 cos theta, we'll get a minus 64 cosine cube theta d theta. Alright? Can pull out minus 64. Okay, how do you integrate cosine cube theta here? Any idea?
Separated into cos squared and cos squared theta and cos squared. Then
Yes.
the cos squared theta we use the trigo formula to change that.
We have
Yeah.
seen this before, right? For sine cube, isn't it? So we rewrite cosine cube as cosine squared theta times cos theta, and then we further use the identity to change cos theta into 1 minus sine squared theta, right? Yeah, so now this integral becomes minus 64 over 3. The integral 3 pi over 4 up to 5 pi over 4. 1 minus sine squared theta cos theta d theta. Okay, what next? What next?
Substitution.
Yeah, substitution u equal to sine theta, isn't it? Yeah. So now you have 1 minus u squared, and here du is cos theta d theta, so du. Now the upper and lower limits also change, right? What is sine of 3 pi over 4? Square root 2 over 2, isn't it? Square root of 5 pi over 4 is minus, right? Minus square root 2 over 2. Yeah. And because of the minus sign, we can interchange the upper and the lower limit. Okay, I leave it to you to simplify this integral. Alright? You should be able to solve this. Yeah. So first is to get the diagram correct. Yeah. The diagram correct, and then also to get the limits correct here, or the polar coordinate. Any question? Okay, now let's discuss triple integrals. Let's discuss some questions related to triple integral. For example, okay, let me pick one example. Find the volume. Find the volume of the solid region that the cylinder the cylinder is given by x squared plus y squared equal to ax cuts out of the sphere of radius a centered, say, at the origin. Okay. Find the volume of the solid region that the cylinder x squared plus y squared equal to ax cuts out of the sphere of radius a centered at the origin. So this solid region is the intersection, right? Intersection of a sphere and a radius and a cylinder. The volume involves triple integral, isn't it? For the evaluation of the volume, we need to apply the triple integral. Remember, the volume integral formula is this one. So what are the limits? What's the limits? Okay, so what is it that we need to do? As before,
Sketch out the
to sketch,
diagram.
just to sketch this solid region G. So a sphere, we know what a sphere looks like. We know what a sphere looks like. Okay, that is the sphere. Okay, something like this. Radius A, right? Centered at the origin, radius A. Okay, where is this cylinder? This cylinder, see, on the xy plane, it is a circle, isn't it? X squared plus y squared equal to ax. Okay, what is this? This can be written as x squared plus ax plus y squared equal to 0. What is the center? You see, on the xy plane, it is a circle, right? So what is the center? This is a circle on the xy plane. What is the center? Again, completing the square. Okay, if I complete the square, this becomes x squared plus ax plus what? Plus or minus what?
Plus A minus A.
No. The coefficient of x here is a, right? We divide that by 2 and then we square it. So the result is a squared over 4. So we add and subtract a squared minus 4. Yeah.
Is it negative ax minus ax?
What is it? Oh yeah, you're right. You're right. Should be minus. Yeah. minus. Thank you. Minus ax, yeah. So the coefficient of x is minus a. We divide that by 2 to get minus a over 2, and then we square the result. So that gives a squared plus 4. So when you add a squared plus 4, you need to take away also minus a squared plus 4. So in this way, you will get x minus a over 2 squared plus y squared equal to a squared over 4. So it is a circle centered at a over 2, right? Centered at a over 2 of radius a over 2 also. Yeah. So the on the xy plane we have a circle like this, yeah, on the xy plane. So it is a cylinder. Okay, in 3D it is a cylinder. Yeah, it is a cylinder. So, can you imagine this object G, which is the intersection of a sphere and cylinder? Must be something that looks like this, right? Isn't it? Must be that looks something like this, the intersection of a cylinder and the sphere. This is the object G. Am I right? Maybe should go all the way up to here. Yeah. So the object G is the one shown in red there. So Z is bounded by the upper hemisphere and bounded below by the lower hemisphere. Yeah. And XY is in this green shaded. It's in this green shaded region here. So as you can see here, Z is bounded above by the upper hemisphere. Right? The equation of the hemisphere is x squared plus y squared plus z squared equal to a squared. So the upper hemisphere is positive. This one here. Positive. A squared minus x squared minus y squared. The lower hemisphere is minus a squared minus x squared minus y squared. Okay, what about x and y? What about x and y? This is a circular region here, right? The green shaded region is a circular region. If I were to sketch the circular region, it is over here. This is y. This is x, right? It is centered at a over 2. A over 2 here. This is the circular region. Yeah. A over 2. This is A. What comes to mind when you have a circular region?
Cylindrical.
Polar coordinate, isn't it?
Yeah.
Yeah. So what is the equation of this circle in polar coordinate? So going back to this equation, we have r squared equal to x squared plus y squared is r squared, and a is r cos theta. So that means r is a cos theta. So this equation of a circle here is r equal to a cos theta. And theta is from 0 up to, because it is a complete circle, theta is between minus pi over 2 up to pi over 2, right? Because it is a complete circle. Remember, you have studied polar coordinate, polar graph in the what? In mathematical method 1. So therefore, the volume now can be written using cylindrical coordinate. Yeah, the idea is to use cylindrical coordinate, and in cylindrical coordinate, this is square root of a squared minus r squared. This square root is the same as a squared minus r squared. Yeah. So what is the volume? What is the in cylindrical coordinate? R becomes dv becomes r dz dr d theta. So z is between minus square root of a squared minus r squared. Yeah. Okay. And r is between 0 up to a cos theta, and theta is from between minus pi over 2 up to pi over 2. Yeah. Okay. So this is the setup of the volume integral using a cylindrical coordinate here. The idea is to use cylindrical coordinate. And the object G is symmetrical, isn't it? It's symmetrical. It is 4 times the volume in the first octant. Right? The volume is 4 times the volume in the first octant. So if I use the symmetry, this is equal to 4 times the volume in the first octant. So it is 0 up to pi over 2, 0 up to a cos theta. Here's from 0 up to the square root of a squared minus r squared. Okay, I leave it to you to show that the answer is equal to 2/9.
Doctor,
Thank
how
you.
does symmetry makes the equation like that?
Just a minute.
Uh,
Yeah. What is it? How the symmetry?
how the symmetry of the diagram makes the equation like that? Yeah.
What
How?
equation? 4. You
Yeah,
mean
yeah, the
4 times?
the four. Yeah.
Because it is symmetrical, right? The object is symmetrical. It is 4 times, isn't it? It is like this, 4 times, right? Of this object in G. This is the
Oh,
shape of the object in the first
Yeah, you
quadrant,
can cut
right?
into half. You can cut into half.
To 4. They're symmetrical, right? Yeah. So the total volume is 4 times the volume of the object in pink, in purple or pink. Yeah. I mean, if you notice that, it will simplify the computation here. Okay, so I leave it to you to practice and show that this is equal to this value here. Any question? I've already solved this problem. Yeah. This is a challenging problem, just for um, this is for test two. Maybe this is too challenging, but but you should learn how to. This is just to show you how to construct the what the triangle, the volume integral. Yeah, how to determine the bounds in terms of cylindrical coordinates. This is what that you need to learn, right? Yeah, the constructions. Yeah. Okay. Okay. Another application is the what? The centroid. Oh, and then what? The center of mass. Yeah. I think I've discussed with you something about this finding center of mass in class, right? Center of mass in class. Yeah, this one here. G is cylindrical. Yeah, I've discussed this in class. Yeah? So this one is involving the what? The cylindrical coordinate here. First, we need to calculate the mass. Um, and then where the center of gravity lies in the on the z-axis. Why? Why the center of gravity must lie on the z-axis? Because if you observe this, then immediately you can say that x bar is 0, y bar equal to 0. So you only need to calculate z bar. And this is the formula to calculate. But what is z bar? Z bar is the moment. Yeah, the moment m sub xy over m. Yeah. So this is the formula to calculate the moment about the z-axis. I think I've explained to you why. Because G is a cylinder, right? A cylindrical object, and it's a symmetrical with respect to the z-axis. And also look at the density function here. It is also symmetrical with respect to the z-axis. Yeah, 20 minus z squared. Yeah, so the density is evenly distributed, around the cylinder with respect to the z-axis. Yeah, so because of these two reasons, can conclude that the center of gravity lies on the z-axis. I think I did not discuss for the spherical. I did not discuss that for the spherical. Okay, let's try this problem. This is a sample test 2 problem. Yeah. A solid is bounded below by the sphere. Should be the word by here. By the sphere x squared plus y squared plus z squared equal to 4z, and above the cone z equal to square root of x squared plus y squared with density rho delta xyz equal to 1 over z squared. And the mass is also given here, m equal to 4 pi ln2. Find z bar, which is the z coordinate of the center of gravity. Yeah. Okay, look at the sphere, the given sphere here. It is the left hand side, the right hand side is not 4 but 4z. So this sphere is not centered at the origin, right? What is the center of the sphere now? Yeah, we need to make a sketch of the solid, yeah? The solid. Yeah. So we are given this sphere, x squared plus y squared plus z squared equal to 4z. So the center is no longer at the origin. Where is the center of the sphere? So you complete the square. Okay, complete the square for the term for z here. What is it? What is it? What do we add and subtract here?
4 minus 4.
Yeah, plus 4 minus 4. Okay. Yeah. Look at the coefficient of z is minus 4. We divide it by 2 and then we square. Yeah. So to get 4. So when we add 4, we must take away 4 to balance the equation. So this can be written as x squared plus y squared plus z minus. You see the sum of this three term here is z minus 2 squared, right? Yeah, so z minus 2 squared. And we have minus 4 on the left, so it becomes 4 on the right hand side. So what is the center of the sphere? Yes?
0, 0,
0, 0,
and 2.
and 2. Yeah. And what about the radius?
2.
2. Yeah. Because 4 here is 2 squared. See, in general, this is the equation of a sphere with the center at ABC and radius R, right? This is the general equation of a sphere. Yeah. So we have a sphere. Let's sketch the sphere. Let us sketch the sphere. Okay, it is of radius 2, right? Radius 2 here. Okay, what is the other object? The other surface is a cone. You see, you should know all these common surfaces here. z equal to x squared plus y squared. It's a cone that opens upward. Okay, it is a cone that opens upward. Yeah. Oh, I'm sorry.
Doctor, is
Yeah, I'm sorry.
the sphere.
Yeah. I made a mistake. It is no longer centered at 0, right? It is centered at 002. Yeah. Okay, yeah. Sometimes I also made this careless mistake, you know. But we should, always check your calculation, as you go along. Always check your calculation. So now we have a sphere centered at 2. Yeah, so it looks something like this, of radius 2. This is y. This is z. Yeah. So it is centered at 2 of radius 2. Yeah, 0. So here is 4. Okay. And then we have a cone, right? There's also a cone. It is the vertex at 4. It's a cone that opens upward. So the cone then intersect the sphere. Right? Intersect the sphere. Okay, I can remove this extra line. Okay. So what is the shape of this object G? It is you can read the question again. Bounded below by the sphere. It is not an ice cream cone, right? Because bounded below by the sphere, it's not bounded above by the sphere and bounded below by the cone. That is an ice cream cone. But it is bounded below by the sphere. Yeah. This how is it? I need to use the broken line here. It is actually the object lies below the ice cream cone, isn't it? The G here is actually below the ice cream cone. Yeah, it is below the ice cream cone and bounded by the sphere. It is the sphere below the ice cream cone. This the object G is the sphere below the ice cream cone. Yeah. So what coordinate system should we use here? It's related to sphere. So what comes to mind?
Spherical coordinate.
Spherical coordinate. Okay. Should think of spherical coordinate here for this kind of problem here. So what is G rho? What is
Didn't notice
G?
that. Yeah, we
Yeah.
tried that. We already tried this, but we we wrongly taken the part. We take the ice cream cone.
You tried. Okay. It's not the ice cream cone, yeah. It is the sphere under the cone actually. Part of the sphere under the cone. Yeah. It's like a cup, isn't it? Some kind of a cup. Yeah. Okay, so let's determine the object G in terms of spherical coordinate. Rho, theta, and phi. What is the row between what and what? Row, the sphere. What is the sphere in terms of a spherical coordinate? Yeah, what is the sphere in terms of a spherical coordinate? Go back to this one here. Yeah. We have x squared plus y squared. Yeah, go back to the equation of the sphere. X squared plus y squared plus z squared equal to 4z. Now, in spherical coordinate, x squared y squared plus z squared is rho squared, and z is equal to what? Rho cosine phi, isn't it? In spherical coordinate. Let me show you the equation again. Yeah, here. See here? Z is equal to rho cosine phi, right? Z is equal to rho cosine phi. Yeah. So this implies rho equal to 4 cosine phi. Okay, rho equal to 4 cosine phi. That is the equation of the sphere in terms of spherical coordinate. Yeah. So rho is between. So we know. So therefore, rho is between 0 up to 4 cosine phi. Okay, what about phi? Phi is from where to where? Remember, phi measures the angle, right? Phi measures the angle. Phi measures the angle. So so phi is from the surface of the cone until the sphere.
Doctor,
What is the cone makes a what angle?
pi over 4.
Pi over 4, yes. The cone makes an angle pi over 4 until the sphere.
Doctor, can we
Yeah?
see again the question?
You want to
Because
look
the
again
question
at
is
the
below
question?
the sphere.
Yeah. It's bounded below by the sphere and above by the cone. So it is not an ice cream cone, yeah? Not an ice cream cone.
Doctor, so the above is on z axis, right?
Z
The above
axis.
mean positive z, is it? Above the cone under the sphere, doesn't it means the cone and ice cream cone?
No,
Very confusing.
it is the other way around. You see, the ice cream cone means it is bounded above by the sphere, bounded below by the cone. You see, the ice cream cone looks like this, right?
Uh-huh.
It's bounded above by the sphere, below by the cone. This is the
The
other way
sphere
around.
is inside, is it? The
This is the other way around. It is bounded below by the sphere and bounded above by the cone. So it is part of the sphere under the cone.
above the cone wall, is it? Is it above means the z axis above z axis? So that means it's the cone above the
Above the
cone.
cone. Uh-huh.
So it's the cone, is it? Above the cone.
No, it is bounded above.
Above is
By. There
on
should
z
be the word
axis, right?
by here. There should be the word by. Bounded below the sphere and above the cone.
Below the sphere, above the cone.
Really? Oh, so it's an ice cream cone. Yeah.
Yeah, very confusing.
A solid is bounded below the sphere.
The sphere is pointed downwards, so is the north hemisphere, is it? So the cone.
Oh, no. No, it is bounded below the sphere.
Below. Yeah, below. So
And above the cone. Oh, yeah, it is an ice cream cone, actually, right? Yeah. I got the question here. It is bounded below the sphere, not by the sphere, and above by the cone. Below. So it is below the sphere. Okay. Yeah, it is actually the ice cream cone here, actually. A solid is bounded below the sphere and above the cone. Oh, yeah, you're right. So actually it is a ice cream cone. Yeah. Sorry, my mistake. My mistake. So it is the ice cream cone. Yeah. Okay. Yeah. It's bounded below the sphere and above the cone. Yeah. So it is the ice cream cone here. Yeah. It is the ice cream cone. So rho is correct. Rho is correct. Yeah. Rho is from 0 up to the sphere for cosine phi. But phi should be from 0 up to pi over 4. Yeah. Phi is from 0 up to pi over 0 up to pi over 4. Yeah. Okay. Thank you. Okay. Uh, it's bounded. Should we should say that the solid is below the sphere and above the cone. Maybe we shouldn't have this word there. A solid is below the sphere and above the cone. Yeah. Solid is below the sphere and above the cone. Yeah. So that means it is an ice cream cone. I thought this is bounded below by the sphere and bounded above. Yeah, the question must be correctly written. Yeah. So what about theta? Theta is this. Theta is what? It's this one, isn't it?
2 pi? 2 pi is it?
Yeah, from 0 up to 2 pi, right? Yeah, this is the region R here. Yeah, so theta is from 0 up to 2 pi. Like this, yeah? Yeah, so therefore what is it that we want to find? Mass is already given, the z coordinate. Delta is 1 over z squared. Uh, So the object, the ice cream cone G has theta between 0 up to 2 pi, and phi is also bounded by numbers 0 up to pi over 4, but rho is no longer bounded by numbers from 0 up to 4 cosine phi. Yeah. Okay, what is z bar? Remember, go back to the formula. What is z bar? This is z bar. Z bar is mxy Yeah. You need to recall this, huh? Recall this fact. The center of gravity should lies where? Where do you think the center of gravity should lie?
Along the z-axis.
Along the z-axis, yeah. Because the why? Because for two reasons. Because G is symmetric, right? With respect to the z-axis, and look at the density also. The density function is also symmetric with respect to the z-axis. So for these two reasons, the center of gravity lies on the z-axis. Yeah. Okay. So it is enough to calculate z bar here. Z bar. So m is already given in the question. So we need to calculate mxy. Moment with respect to the z-axis. Which is this one. Z delta xyz dv. What is delta? What is the density function here? 1 over z squared. The density function is 1 over z squared. So the triple integral is 1 over z of 1 over z dv. Okay. So now we use the spherical coordinate. What is z? Z is rho cosine phi, and dv is what? dv is rho squared sine phi d rho d phi d theta. Okay. So the inner integral is with respect to rho, the innermost integral. So rho is between 0 up to 4 cos phi. Phi is between 0 up to pi over 4, and theta is the 0 up to 2 pi. So this is the one that we need to evaluate. So one row cancel out. Okay, one row cancel out. So we need to integrate with respect to rho first. Integrate with respect to rho first. We have sine phi over cosine phi. We integrate rho, right? Integrate rho, we get rho squared over 2. And rho is from 0 up to 4 cosine phi. Yeah, then we have d phi d theta. So if we substitute, what do we get? Rho is 4 cosine phi. So rho squared is 16 cosine squared phi. Divide that by 2, we get 8, right? So I can pull out the 8. We have sine phi over cosine phi times cosine squared phi here. Cosine squared phi. D phi d theta. Yeah. D phi d theta. So, yes, I can write this as a product. I'm sorry, this should be 2 pi. Yeah, 2 pi. And what do you know? We can write this as the product of two single integrals. One cosine cancel out, so we get sine phi cosine phi d phi. Okay. Yeah. So the first integral is clearly 2 pi. For the second integral, what should we do?
Use substitution. And
Or
equals to
or this is equal to sine 2 phi, isn't it? Over 2, right? Yeah, you can also use this identity. So you can integrate sine 2 phi. Yeah, integrate sine 2 phi, what do you get? So here we have 16 pi. We have 2 there as well. So we have divided by 2. So that means 8 lah. This one is 8. Yeah. Okay. So we integrate sine 2 phi. What do we get? We get minus cosine 2 phi over 2. Yeah. Yes, okay. When we integrate sine 2 phi, it is minus cosine 2 phi over 2. Yeah. So again, so 8 over 4 is 2. We have minus 4 pi. First, we substitute phi equal to pi over 2. We have 2 phi there, so we get pi over 2 minus cosine 0. Cosine pi over 2 is 0, right? 0 cosine 0 is 1, so the answer is 4 pi. Yeah. This is correct. This is correct. 4 pi. How come it's outside? How come it's outside the sphere? The radius 1. What is the radius? 2. 4. Nice.
Doctor.
Can we check this again?
Yeah, here. Sorry.
Yes. How come I expect it to be inside the sphere. Should be inside the sphere. 1 over z, yeah. That is correct. 1 over z squared. It's 1 over z. Mxy z, yeah, z times delta. Delta is 1 over z squared, so that is correct. 1 over z, that is correct, yeah. This is also correct. And we integrate rho, we get rho squared over 2, so that is also correct. Then we do the substitution, so we get 16 cosine squared phi. Divide 16 over 2 is 8, so that is also correct. So y and then yeah, that sine phi cosine phi is also correct. Sine phi cosine phi is sine 2 phi over 2, that is also correct. We integrate
Doctor, do you left out the z? Moment xy is equals to integration of g, z and density. So left out a z there. Is it?
I have Z here, you see?
Oh, yeah.
I have Z there. How come the Z? Oh, this is not Z bar. This is MXY. I'm sorry. It's not finished yet. Z bar is MXY over M, right? So what is M? What is M? The mass M. The mass M is
4 pi
what?
over ln 4 pi ln
4
2.
pi over ln 2.
4 pi 4
4
pi
pi
ln 2.
ln2. Yeah, 4 pi ln2. So this is need to be divided by 4 pi ln2. Yeah, 4 pi cancel out. Okay, what is 1 over ln2? Can somebody tell me? I hope it is less than 4.
1.4427.
1 over ln2, right?
Uh,
1.27.
1.4427.
Yeah. Okay, so this is less than 4. So this Z bar is within the sphere. So actually the center of mass is X bar, Y bar, Z bar, 0, 0. It's on the Z axis, 1.4427. Okay. Why is it it is along the Y? Why is it the center of mass is 0? Because why? What is the reason?
The solid is symmetrical.
Yeah, G, both, both the object G and the density function, right, is symmetric. Yeah, is symmetric with respect to the z-axis. Yeah, symmetric with respect to the z-axis. Both. This must be, not just one, but both of them. G is symmetric with respect to z-axis. The density function also only involves z, right? Z squared. Yeah, it is symmetric with respect to the z-axis. Okay, I guess that's enough for some review. So you can wish you all the best for your. I will also put this in the e-learning, what we have discussed today. So so it seems that I cannot. If you look at the course information, if you look at the course information, you are a little bit behind here. We should discuss line integral this week, isn't it? So no, I haven't discussed with you divergence and curl also. So I think we have to do a makeup class, we have how many? 3 weeks remaining, isn't it? We have 3 weeks remaining. So I think we need to do a makeup class, yeah. Can we do a makeup class next Sunday? Is it okay with you next Sunday at night time? Is it okay? Do you have any exam next week? Any test next week?
Next Sunday,
Do you have any test next
apa hari bulan
next Sunday?
6 is it?
Sunday 6, yeah, 6.
6
Cannot. I cannot on Sunday. Any other day? We have a class on Tuesday and Wednesday. What about Monday? No, not Monday, because you have a class early morning. What about Thursday?
Thursday cannot.
Thursday we have test.
Okay, okay, maybe 13 June. Is it okay? 13 June?
13
Next,
June.
Sunday, 13 June, to do a makeup class. Is it okay?
Tonight, Elder.
At night, yeah, night
Uh,
time.
I have test. Electronic test.
Okay. Yeah, so many tests. Mm. Next week, say on Monday or maybe Thursday. Thursday on night time, is it okay? Thursday night on 10th. Thursday night at 10th. You can also do it on Wednesday night next week. Wednesday night, is it okay? Wednesday night next week, 9th, or Thursday night.
I think Thursday kind of do it.
Thursday, yeah?
Uh,
Thursday
yeah,
night
this.
on the 10th. What about, is everybody okay?
Thursday night, okay?
Thursday night should be okay.
Okay, sir.
Okay, yeah?
Yeah.
Okay, on the 10th,
Okay,
yeah?
lah. Okay.
Alright,
Thursday night.
so Thursday night, let me put this also in writing. So we have a makeup class. Makeup class on the 9th. Was it on the 9th? 9th, right?
Yeah, 9.
9th. This is on Thursday.
Thursday is 10.
10,
sir.
Dr. 10.
10? 10.
Not 9,
Oh,
10.
9, 10. 10. 8 p.m., right? 8 p.m. Say until 9:30 p.m. Okay?
Okay.
Okay, thank you. Thank you very much for your attention. Let me first show you the
And
before we stop, let me show you the class attendance, huh? The class attendance. QR code for the class attendance. Mm. Okay, what is 11 11 a.m. Okay, there you are. The QR code for the attendance, please scan. And you may leave the class after